Hello everyone, welcome back to the Node Concept. This is Eddie and with me Shubham from Blenderphile, and today we have 7 nodes, actually not 6 but 7, and those are, as you can see, separate and combined HSV, RGB and XYZ. Also we have a separate node called RGB to black and white. So these nodes are not quite used, and especially this last one, RGB and black and white too. So let's just get started. What we are going to do is we are going to add in an image as a plane, and we select a texture. Hey, texture folder is gone. What? Alright, so back to textures, and we're gonna select image. Let's see, a colorful image. Let's go with this one. Okay, background 5. You can choose any image you want just for testing purposes, and I guess that image is quite good. Alright, let's just add it in. Import image as plain, just scale it up. Okay, close. Alright, so we have our image. We'll be putting up node editor over here, and we have our image nicely over there. Okay. Alright, so we're gonna remove this, and we're gonna select control left click, and we have the other over there. Alright, now press Shift A and go to converter. We'll add all of them. Firstly, RGB to black and white. And if you connect this, you can see what it does. It converts it from color to black and white. I don't think it needs more explanation than that. Just simple. Converts it into a black and white value. So now you can see it's black and white. Alright, so that's it. RGB to black and white. Next we're gonna add in separate and combine. A lot of them. 6 nodes away. Alright, so firstly separate RGB, right? So what it does is it separates the R channel, G channel and the B channel, which means the red, green and blue channels over here. So if you see, our image textures made up of many colors, and you can see there is red over here, green, blue, purple, all sorts of things. So these are actually made up of different colors. So like red is red, of course. We have green is a mixture of blue and yellow and things like that. Purple is blue and red. So it separates the R and G and B. So the way it separates is, let's see, let's show you. Oops. Input, where's that? Okay, so you can see over here. Alright, so this R, G and B. So R of 0 means there is no red at all in that place. So 0 over here, that means there is no red color over there at all. But you can see there is black and green, a bit of blue over there, but no red at all over there, right? And R1 means all of red over there, like these spots and these lines, because white color is made up of all the colors and combined into one spot over there. So white color will contain all of them, R, G and B, to the intensity of 1, right? And then a middle value will give you a grayscale over here. So you can see black portions are having no red at all, and white portions are having full red. Similarly is the green and the blue. So you can see there is no blue at all at these places. There is light green and red, which gives you a yellow color over there, and no blue at all. So that's how separate RGB works. Another thing is its partner and the opposite, which is the combined RGB. So it takes a value between R, G and B, something like that, and gives you a color. So RGB and value 1 gives you white color, and you can play around with that. Now if we combine R to the R channel, G to G, and B to B, you can see we get our original picture back. So removing this and making this 0, you can see we have different color patterns over here. So you know, sometimes if you get bored, you can just add in an image texture and you can just play around with this, connect them randomly to any places, and you have a new texture available to you to play around with. So this is how combine RGB and separate RGB work. So that's basically this. Next is the separate and combine HSV. Alright, so let's just add them. Alright, so now as the separate RGB does, it separates on the basis of red, blue and green channel. The HSV, what it does is it separates it on the basis of hue and saturation and the value which it is having. Where is that now? Oh, I deleted that. Where is that? RGB, okay. Alright, so as you can see, HSV. Now we have a huge channel between 0 and 1, saturation and value. Right, so now if you left click over here, control shift left click. So now you can see it is showing you the hue. So over here these places have a hue of value 1 and these places have a hue of value 0. Similarly the saturation, so these portions are completely saturated, so saturated white color as you can see, and then there is the value. So it shows you these are having saturation of 1 and value of 1, so things like that. You can just, you know, you'll figure it out. Right, and then there's the same thing as the combine, so it combines them, so V to the V, H to the S, and H to the H. Okay, and now you can see our origin texture back, and again you can just, you know, play around with these and connect them here and there, and you'll get completely new whatever this is. It looks bad. It looks bad. You can play around with that, not with HSV. It looks really weird. Alright, lastly is the separate and combine XYZ. Right, so this is a one which uses a vector input, and we'll be showing you, of course, we'll be showing you. Alright, so for that we need is a vector. So we'll go to the input and add in a texture coordinate just for this purpose, and we don't need this anymore. Oops. Oh well, alright. We'll add in a UV sphere. Alright. And add that material back. Okay. Right, so if we press Ctrl Shift left click on generated, you'll see we have a nice random color ball over here giving us the UV coordinates, the vectors. So if we plug that in over there now, bam. So alright, so from top view you can see it tells it you know, between 0 and 1 which direction the face is actually facing. So if we go back to go to the edit mode and turn this thing on, ta-da! Now you can see the lines which are following the x-axis. Let's just add the vertices. Right, so now we have the vertices as well, giving up normals. Alright. So the lines which are facing towards the x-axis. So thing to be noted, this is negative x and this is positive x. So this this direction it is 0 and this is 1. Right. So you can see the faces which are facing completely towards the x-axis will be having a value of 1, and which are not facing the x-axis, which is these points over here, will be giving you a black color. Right, so that is how separate XYZ helps. It takes in vectors. So and value between them, like for here, it's following the y-axis. So if you see, it's, you know, kind of midpoint, not midpoint. I don't know how to explain. I know how to define it. It's actually not completely facing the x-axis. It's partly facing. So that's why it's giving, you know, a 0.5 value on the x-axis. So 0.5, if you see, oops, over here, you'll get is red color. Oh, okay, it's vector. So that's bad. We can't show you actually. Alright, Anyway, so that is what the separate x, y, and z is doing. So next is y. Y will give it on the y-axis, and z will give it on the z-axis. So now you can see all the faces which are facing on the z side. Right. So you're gonna have different what do we call that? Texture coordinate. Right. So generated is for generated UV space. Normal. The thing I was telling you is about the normals actually. So not every face is facing towards x-axis. Over here. Okay, so now you can see. Right, so these faces are actually not, I mean, at this y point, the x value is 0, so 0 starts from here, and from there no other vertex or face is facing towards the x. Everyone is facing towards the negative x. That's why it's getting a value of 0. After this side, on the positive x direction, what you'll see is every face is facing towards the x-axis with some value. So they can have a vector difference between, you know, multiplication of y and x that will give direction on that side. Alright, so that is the thing, and I'm gonna add a UV unless you have a UV unwrapped. Okay, that looks weird. Weird. Anyway, so that's how it works. You can play around with that. So next is the combine. You can combine them, and you'll get is the same normal. Okay, same input which we get over here. So normal input and combination output. So you can again play around with them and get some really weird results. Just in case, you know, getting bored and want to have something different. Alright, so to create some kind of a dust effect, dust basically collects upon the top side. You can use the normal and separate only the z, and you can use the z as a factor. So as it is returning a value, you can use this as a factor to have some kind of a dust fall off over there. So you can play around with that, and then you can add in a color ramp, and you can play around with that. Now see, we have some dust factor over here. Now you can add in a color over there, and for example, let's just show you. Okay, we'll use that as a factor, and let's have dust color over here on top, and our color. Oh, it was okay. So there you go. So we have a dust falling on top of our blue ball. Oh, this looks really noobish and bad. I'm talking about when you are making your materials, you can actually use them. So if you want to see a tutorial on this thing, you can refer to Enterprise's Blender Guru tutorial where he tells about adding this to your models and scenes. So you can see that video. We'll be having a link in the description. You can check it out from there. Alright, so that is basically it for this tutorial. We did 7 tutorials, and it took about 15 minutes, so that's basically good. Alright, so we hope to see you in our next video. I hope you learned and enjoyed the video, and next we'll be talking about 2 more nodes, which are the wavelength and the black body. Total physics stuff in there. Totally physics. So if you are a very science nerd, that's a good video for you. And so to see that, stay tuned, subscribe, and follow us on Facebook at facebook.com/Blenderphile, and we hope to see you in our next video. Bye.